screenshot number 1, we try to create hello module by hello module.c and make file. And for hello module.c, we have two functions. The first is initialize and we print kernel info in DMESG with my student number setting here and the clean exit, and we execute it. And this is the make file for hello module. Screenshot number 2 is the make process of the hello module. For screenshot number 3, we run the hello module by sudo insmod hello module.ko, and then we open the second terminal and open DMESG, and we can see that it runs successfully with the initialize here. Function initialize hello from OS project number 3. For screenshot number 4, we run command lsmod for listing out all the module we are running right now, and we can see hello module we run here, and not a lot of module run by kernel here, and here. And we try to filter out the hello module, so we type lsmod and grep hello module, and we have hello module here. For screenshot number 5, after we run the module, we unload the module by rmmod, and we have DMESG here, and it says we have unload the module. Screenshot number 6 indicates that if we unload the module and we still run this module, hello module, and we found nothing because the module has been removed. For screenshot number 7, we try to create another module called params module. First, we define all the variables we need here and set modify value to 0. And then we run initialize here, and if modify value equals to 1, we run we set the variables to the value, and those is still the same as the initialize. And then we run the module. And this is the make file for params module. For screenshot number 8, we just load the module params module and remove the module. And we can see in terminal number 2, we have kernel information here, which indicates that the initialize and amount the module is successful with the original unchanged variables here. Screenshot number 9, we have something different, which we load module is the indicate parameters value. Here we set modify values equals to 1. And we can see in the terminal number 2, we have initialized the module, but this time because we have set if modify value equals to 1, we do different setting to variables. So here we have student ID equals to -1 and secret value equals to -2, and we have a new message here. This is a dummy message. For screenshot number 10, we want to check the module information, so we type the command mod info for params module, and here we list out all the different information for the module here, file name, description, author, and license. All of them are set by the program params module itself. And then we unload the module by rmmod, and then in terminal number 2, we can see that it is amount successfully. For screenshot number 11, we run the params module again with more indicates parameters here, student ID and secret value. And in terminal number 2, we can see that the student ID and the secret value is changed to the value we just indicate. For screenshot number 12, we go to the file path that stores the parameters value for the params module, and we open the file for secret value, and we change it from AAA to 7777. For screenshot number 13, we remove the module after we modify the value here. And then we can see that in terminal number 2, it indicates that student ID is still the same because we didn't modify it. But for secret value, it has changed to 7777 since we modified it manually. For screenshot number 14, we still run the params module with the indicated value, but this time the parameter's name is invalid. What will happen? And in terminal number 2, we can see that it says params module dummy student ID is ignored because it is invalid parameter, and all the value will change will still be the default value. For screenshot number 15, we want to dynamically load the params module number 2 by the loader unloader.c here, and we build a module by makefile. For screenshot number 16 is the content of loader unloader.c here. First, we define variables here, and then the module loading section, we open the module of its name and the mode, and we allocate space for the module, and we call it by initial module here, and with the parameters we want to pass. And after passing enter, we unmount the module here by delete module with the mode, and we clean up the space the module just took. And for params module 02.c is similar to the params module, and then is the make file here. For screenshot number 17, we build the loader unloader.c by GCC and build the module by make, clean, and make, and then we run loader unloader here, and it shows up all the message and say module is mounted. So we check terminal number 2, and the kernel message it just say that the params module number 2 is loaded successfully. And then for this module, we also got params module 02 here. For screenshot number 18, we press enter for unmount the module, and it says down. So we check the kernel info here, and it say clean exit here, and it means that the module is unmounted successfully. And then if we try to run, try to find the module here, by this module, and if found nothing, and if we check the parameters here, is no such file or directory. For screenshot number 19, we try to create calculator module by ourselves. First, we look at the calculator.c here, and we have additional definition here and with initial module and delete module for dynamically load module and delete module. And we have all the parameters we need and define here. And then we read the input from ARGV, and we first charge the operation parameter. If it is add or sub or MUL, we call the specific function running it. And if there is no error, then we print out the result. For addition, subtraction, and multiplication is basically the same logic. First we allocate the space for the parameters. Params new is the string we want to pass to the module, and then we call set param string load module, and we get a result by calling get result and unload module, and then we return if there's any operation error signal. For set param string, we combine input 1, input 2, and operation parameters into one simple string called param, and which is the params new for 3 of these functions. And then we code load module, and load module is the code for dynamically loading module with the name, mode, and we allocate the space for it and code it by initial module, and with the parameters here. And we get a result by access the file here, result parameters here, and if the file is not exist, then it will print out the error message, or it will read the file and assign it to result. Then is unload module, and we unmount the module by delete module with the name and the mode, and we clean up the space that was used by the module. Next, we look at the calculator module.c, and first we define all the variables we need here. First param, second param, operation param, and result param. And then is the function initialize, and we have if, and we compare the string. If the operation string is equals to add, sub, or multiplication, we set the operation parameters to its value, add, sub, or MUL, and we calculate the result by adding it, subtracting, and multiply it. If it is not 3 of these operation parameters, you will set the result parameter to minus 99999 and return 0. For clean exit, it's just the message for we unmount the kernel. For screenshot number 20, we try to run the calculator module here by sudo calculator, and with the three parameters here: first parameter, second parameters, and operation parameters. And it will in terminal it will print out the value it calculates here if it is the correct operation parameters. Then we can see that here correct. And for the undefined operational parameters, it will just return minus 99999 here. And if there is no such parameters, it will also return minus 99999. And then we check the terminals here. You will see that for all of these record we run here, it just print out the corresponding kernel info in the DMESG, and we can see that if the operational parameters is not valid, for example 5, 10 mode is valid and test is not valid, okay, 5, 10 is here, but the next one is minus 5 and 7, and we can see here minus 5, 7. So if we enter invalid operational parameters here, it will not enter into the module. It will not load the module. And that's all for my project number 3, and hope you will like it. Bye bye.